Before we get started, I wanted to ask you to subscribe to the Keeping the Lights On newsletter. I want to share insights into the podcast, give you a peek into new episodes, and get feedback from you on show topics and guests. And of course, I will share with you some of the cool restaurants selected by our guests. Click on the subscribe button, a link in the show notes, or on the graybar.com/podcast page, and click subscribe there. Thank you. Running an industrial plant or heavy equipment is a costly endeavor. The last thing an operator wants is an unwanted shutdown. Operators rely on their maintenance teams and contractors to provide the best ideas and products to avoid shutdowns and premature equipment failures. So oftentimes these shutdowns are caused by huge malfunctions of one kind or another, but oftentimes it's just a small problem like leaks or temperature problems in their fluid systems that can cause a bigger, much more expensive problem. So what is the best way for a contractor and operator to think about these specific issues? How can they help? So I've brought on industry veteran Jon Irvine to share his insight into these specialty systems of leak detection and heat trace. First, let's find out, who is Jon Irvine?
Well, Jon Irvine. I've been with Valen Corporation for over 25 years, primarily in our process heat division, but I've got a lot of experience with a lot of our other product lines. I've got a mechanical engineering background, graduated with a degree from University of Washington. I also have a master's in industrial distribution from Texas A&M. I live up in the Northwest out of the Seattle area. Love the outdoors, a lot of outdoor activities, biking, hiking. I grew up playing tennis, play pickleball now, a little bit of golf, anything outdoors I love. So that's me in a nutshell.
Welcome to Keeping the Lights On. I'm your host, Todd Reed, and on this podcast, I connect with the owners and pros who design, build, and maintain our electrical, communications, and industrial world to explore the best ways forward. The smart factory is all about data, collecting it, moving it, and ultimately making change happen. But keeping this data secure and reliable while maintaining worker safety and efficient operations presents many challenges. Phoenix Contact USA partners with customers to help connect, communicate, and automate machines and industrial systems. From Ethernet infrastructure to network security and wireless communication, from remote I/O and gateways to industrial PCs and open PLCs, Phoenix Contact USA can help your factory be more safe, more secure, more reliable, and more efficient. Want to learn more? Click on the show notes or visit graybar.com. Let's get into the show. If I or one of the listeners were to visit you in your hometown, where might you take us out to eat, and why would you choose this place?
Well, so in my travels for work anyway, I've found that you want to go someplace that is kind of the specialty of the region or the area. And in the Northwest, it's seafood. And there's lots of restaurants I would probably recommend that we would go to, something on the water that's really nice, that has, great seafood. Yep. But, if we're going to be creative, I think what I'd really like to do is take you out to the coast and go to a little marina that we used to go to as a family. Rent a boat, go crabbing, get some Dungeness crab, bring it back, and they'll cook it right for you, and you eat it at a picnic table and on the side of the water and enjoy the Dungeness crab. And if you like Dungeness crab, that's the best way to have it.
Wow, that would be awesome. I didn't even think of that as an option. Like I said, I mentioned earlier, I have someone that I'm interviewing, and she said we'd go kayaking around Tacoma and stuff. So I need to go up to that area, and I guess spend some time hanging out.
Tacoma would be great too, but I would say kayaking around the Seattle area. There's so many lakes around just downtown. It's you'd have fun there too.
Yeah, I love kayaking. And well, cool. I look forward to going. Dungeness crab. I don't know. I'm sure I've had it, but I'm not sure how much. It would be pretty much a first time experience.
It's my favorite crab. If haven't had crab before, or if you hadn't had crab before, you would enjoy it.
What are contractors most concerned about when they're coming and talking to you about an issue?
Well, what I see, with the contractors I'm working with, they've got a lot on their plate, a lot going on. Some of them are trying to get a bunch of bids put together. Some of them have projects, and they've got a lot of stuff going on in parallel. And in some cases, maybe they just need a little bit of product, but they need it when they're ready. They need it quickly, and we need to support that. But a lot of times, at least for what I'm working on, they need a little bit more than just product. They need some technical support. They need help picking out the product for a bid, going through a takeoff, maybe some training to make sure that the system is installed properly. Help with the commissioning to make sure that the end user's needs are met. Ultimately, my customer is a contractor, but ultimately our customer is the end user, and they need to be happy with what they get. And both my contractor and myself that's our goal.
Yeah. And what area, it seems like every salesperson or, technical person I speak with at a contractor, at a distributor, kind of a specialty. What would be your specialty? What's yours?
Well, like I said earlier, I've done a lot of different product lines with Valen, but my specialty is really the process heating side of our business. And with contractors, primarily done a lot of work with heat trace. And leak detection is a large amount of the work that we do on the process heat side with them.
Yeah, awesome. So, I guess what are the biggest risks or misunderstandings about those two areas of heat trace? And well, you know what? Actually, I'm going to step back a minute. What do you mean by heat trace and leak detection?
Well, so I guess the heat trace is a product that is primarily used to help maintain temperature on a pipe. It's going to be laid out on a pipe, maintaining their temperature at a specific temperature. And when I say leak detection, a lot of times, in this case, it's liquid leak detection. A lot of times in that pipe, you want to make sure that what's in that pipe stays in the pipe. And we've got the leak detection there to help monitor for that. And so the two products tend to go in the same location, and that's kind of why I become kind of expert on both products.
So regarding heat trace and leak detection, like what are some of the biggest risks and misunderstandings that you see out there?
Well, I guess start with leak detection or with heat trace. Just laying it out on the pipe it's important. If it's laid out improperly, you're not going to get a consistent result, which could lead to leaks, or not leaks, but freeze ups, clogs, and breakage, which could be leaking. So just the overall layout of the heat trace is important, and if you follow standard best practices, you'll be okay.
Sure.
The other things I run into are a lot of piping applications are plastic pipes, and plastic pipe is people forget. They think it's just the same as the other pipe that they did, but they forget that plastic doesn't transfer heat very well. And if you don't have a way to help spread that heat out, you're going to have some problems. So you require aluminum tape. You make sure that's part of the bill of material to help spread the heat from the heat trace to the pipe to get a consistent result.
I assume these are installed later in the project, and like when are they designed? When are they spec'd in? How's that typically work on these type of products?
Right. So heat traces are originally designed on the engineering side, but not sized particularly at that time. We'll help do some of that work to size the heat trace for the application. But typically, the heat trace is not installed until late in the project. You've got the building structures up, all the piping has to be installed, and at that point, the heat trace needs to go on. And typically, what's going on at that time is you're getting near the end of the project, and you've got to get the insulation on. And the heat trace becomes the bottleneck. And it sometimes can be an afterthought, maybe forgotten about. Sometimes contractors are not sure which scope it's in, and so it's kind of added late. So I do find a lot of times, because it's so late in the project, that it becomes kind of a critical need. Leak detection, as we talked about earlier, is even worse, because pretty much everything's installed, and it's one of the last things that goes in. At that point, the crews are a lot smaller. Folks have been moved on to other projects or other part of the project, and you've got limited resources to help install.
Sure.
So those are things that can make it a little bit harder for both these projects.
Yeah.
For products, that is.
Yeah. So somehow you need to think about it or earlier on in the project, maybe like there will be leak detection. So getting it.
Yes, and if there's more preparation, it really does help because we can stage the product, we can get it in house, get it in the warehouse, or maybe even in on the job site already, so that when it is time, it's available and ready to go. A little more planning up front can really help later on downstream.
So what are maybe some of the concerns with leak detection, when it doesn't work right and, what's causing problems in those systems typically?
Well, yeah, as you said, leak detection is more of an insurance policy than anything else. The goal is it never goes off,
Yeah, right.
that nothing is leaking. But as you said, if it does leak, you want to know about it, and you want to know about it as quickly as possible in a lot of cases. Yeah, especially if it's a small leak, you want to know before it's a big leak. I think one of the problems we run into with leak detection, one of the bigger problems we run into with leak detection is nuisance tripping. As a leak detection rope can, in some cases, register a leak when there really isn't a leak. I've seen some technologies do that, and the problem with that is if it does it too often, too much, then it becomes something that is ignored, and then when there really is a leak, it's not addressed. So that's probably one of the biggest problems, and it's important. There's a lot of different types of technologies out there. We work with various leak detection companies that make product, and they all have strengths and weaknesses. It's important to understand the application and why it's being used to pick the best product for the application.
All right. Well, what are some of so basically it's about the right system for the right need or the right need, right? So
yes.
And designing it properly. So like what are some of the, differences in leak detection?
Well, a real common approach to leak detection is you've got a containment area around something that you don't want to leak, and you got a float in there that when liquid builds up, the float detects a leak. The problem with that is, especially if it's outdoors, is you have no idea if it's leaking out of the tank or if it's just rain. And there are the technologies out there that will ignore the rain and only leak or detect the leak of fluids that are leaking out. If it's a hydrocarbon, for instance, it will only detect hydrocarbon. It will ignore water or chemicals. Produced water is a big one these days with fracking and oil industry. You may a lot of that's outdoors. You don't want to detect rainwater. You just want to understand if it's produced water leaking out of the tank. So that's kind of the biggest one is the right technology for the right application. And outdoors is a tough one. I was working on a steel mill application where you've got hydrochloric acid used for pickling in the steel environment, and a lot of the piping was on the roof. This hydrochloric acid leaks out, and they spent over $15 million replacing roofs over the last 5 years.
Oh my gosh.
And they've tried different things. The problem is that what they've tried is will alarm when it rains, when any liquid gets on it. And we're working with them on some technology that will ignore that and only detect on hydrochloric acid leaks. So those are kind of an example of the applications you run into, and ultimately it's kind of fun because coming up with new solutions for these applications is rewarding.
Yeah, interesting. That's why this kind of conversation fascinates me because again, I don't think about it, and then you start digging into it, and there's way more to it than I think initially, which is cool. So what about communication and things like the kind of alarms that these things have? And, if it's a factory where there's people there all the time, or is it a remote, fracking site or something? How does that work? How do you think about communication of the
Yeah,
alarms themselves?
that's probably one of the biggest questions that we get is the communication side of it. A lot of these sites are out remotely, out in the middle of nowhere,
Yeah.
or even if it's in a hospital, and you're detecting a backup generator, the fuel for a backup generator.
Mm.
There are not always people around, and you
Yeah. Yeah.
want, if there is a leak, you want a detection through some sort of an alarm back at a main building management system.
Sure.
Sometimes it's just that's all it is just a dry contact alarm. Sometimes they want to know more than that. They want to know how big the leak is, and you'll need more of a analog signal or bus network to
Mm.
connect to the building management system. And at that point, you can get a lot of information back. We even have systems that work over cellular. So
Mm.
you're out in a field that doesn't have an interconnected communications center. You can get email and text alerts from a cellular signal. So
Yeah.
communication is really important with leak detection. Not that it's not with heat trace, because it is there too, but
Sure.
I think more with leak detection. I do a lot more work with, once we get the system installed and working, I start working a lot with the control engineers or control
Mm.
contractors to make sure that there is communication from the alarm system to their building management system.
Does insurance factor into this? Or are there codes that impact these decisions?
Yeah, that's a good question. Yeah, it is. Again, the leak detection itself is inherently it's an insurance policy. It's there to hopefully never work, but there are applications that require certifications and approvals, especially
Mm.
safety ones. FM is a good example of that. For backup generators, there are FM approvals that need to be met in some cases to that will help you with your insurance policy.
Oh.
You will get your insurance breaks from people like FM Global or other insurance companies if you follow certain guidelines and
Mm.
have FM approved equipment that you're using in your facility. In the end, the savings in your insurance sometimes pays for the equipment being installed.
Oh, wow.
Um,
Okay.
and so it's a good thing to know. It's something that I've studied at least for backup generators. FM 7745 is
Oh.
an important certification that needs to be met, and I've got a couple different supplier manufacturers that meet the certification.
Fast deployment, high reliability, easy integration. Today's competitive industrial landscape has higher demands than ever before, and Phoenix Contact USA understands these needs. Phoenix Contact partners with customers to help connect, communicate, and automate machines and industrial systems. Phoenix Contact's friendly, knowledgeable network of sales professionals across the country is ready to help you solve application challenges. American based manufacturing and logistics facilities give you faster, more personalized service. Want to learn more? Click on the show notes or visit graybar.com. I'm curious. I've been talking to a lot of people about data centers and liquid cooling. Such
Yeah.
a big thing there. Are you starting to? Because when it was proposed, I speak with you, and even during most of our conversations, I'm picturing industrial facilities, generators possibly,
Mhm.
but really I was thinking about industrial facilities like the pickle plant or whatever. Are you seeing more activity in the data center world, or is that something you touch on at all?
Yeah, actually, probably my first. That's kind of where I first got interested in leak detection
Oh,
was on the cooling systems of data centers.
okay.
I mean, a data center server room is packed full of heat. I mean, it's generating a lot of
Yeah.
heat, and the systems that they use, um, cooling systems they use, are traditionally were cooling towers
Mm-hmm.
and water cooled, and they're just really conditioning the temperature of the room itself.
Okay.
But the technology is migrating to even direct cooling, where you've got cooling that's going directly to the servers themselves, and the leak detection in those applications are becoming important. They were important in the past with making sure that the cooling water's not leaking out and dripping on servers. Now it's moving towards making sure that the liquid isn't leaking internally to the servers.
Right.
So we are monitoring that. Again, hope that the goal is it never leaks. But if it does leak, you want to know as soon as possible before it reaches a server or causes major damage. And the cost of the damage to losing data is extremely high.
Okay.
Compared to the cost of the leak detection itself.
Sure. Yeah. Gotcha. Yeah, and it seems like to me a lot of this it's not a ROI is like this is going to help you make money, but are you almost looking at like what it's helping you not spend? Hopefully,
yes,
yeah,
for sure.
okay.
That's what it is. I mean, it's opposed to heat trace. We'll get into that a little bit. It's a different type of cost that we're gaining. But with leak detection, it is primarily what it's saving you from repair costs or damage costs or environmental costs.
Do you see pushback on the cost of doing it, or generally people
I
understand?
do. It can be difficult to install at times, depending on where it's at. Again, the nuisance tripping. If you get a facility that is getting a lot of nuisance tripping, they're wondering, why do we even have this? It's not helping us and it's causing more problems. And then they start ignoring it.
Gotcha. Okay.
A lot of times that's just you have the wrong product in the wrong application, or it was not installed properly, wasn't designed properly. And those are all things that we've learned over time. And
so you mentioned heat trace, which is thank you for that nice transition. We are going to move to that. We talked about what it was at the beginning. It's heating and keeping the temperatures at the right temperature. So what are some of the biggest misconceptions about heat trace though that you come across?
Well, I think one of the bigger ones with heat trace is people just not understanding what it is and what it does. I mean, essentially it's an electric wire, except this electric wire, it heats up. It provides a few watts per foot of energy and is specifically there just to maintain, overcome the losses coming out of a pipe or a tank that we're putting it on. A lot of folks think that it actually is heating up the pipe or the process that's flowing through there, and that's not what it's made for. It's the temperature of the fluid coming into the pipe. All we're trying to do is maintain that temperature all the way along the pipe so that it comes out at the same temperature. In some cases, it's to keep it from freezing.
Yeah.
I've seen applications, another one on the roof, where you've got an HVAC system with 2 feet of pipe that freezes up, didn't have heat trace on it, and that 2 foot bursts, and then you've got water leaking all over the roof, and you got to replace your roof.
Yeah.
So it doesn't have to be a lot of piping, but if you want to keep it from freezing, it's really important to have on there. In other applications, it could be just making sure that chemicals are kept warmer. In warmer temperatures, you still might need heat trace because chemicals or oil oil will flow better when it's at 100 degrees, and you want to maintain that temperature. Chemicals can crystallize when it gets cold, and those crystals can move downstream and maybe clog up small pores or small instruments that then have to be replaced. Some chemicals degrade if they get too cold. So there's various reasons why you need it, but ultimately it's there to maintain the temperature. It's not there to heat it up.
Okay. Where do the trades struggle most with heat trace?
Well, we work with different trades when it comes to heat trace, depending on the project and then whose scope it falls into. I think mechanical contractors I do a lot of work with. They're installing the pipe. They kind of understand the length of the pipe and how much is required, and they installing the heat trace on the pipe is something they're kind of used to, the mechanical side of it. But when it comes to hooking it up to electricity, it's not their specialty. It's not their expertise.
Sure.
And I'll work with electrical contractors that do know electricity and have no problem hooking up heat trace, but laying it on a pipe is more of a mechanical process. It's not their specialty. A little bit more difficult for some trades. So heat trace tends to kind of fall in between the two.
Yeah.
And I have seen some places, there are some mechanical contractors that have an electrical group,
Sure.
and vice versa. Or sometimes you'll have an electrical contractor I'm working with that will sub out the install to the mechanical contractor to have under their own contract.
Gotcha.
Maybe an insulation contractor, because over at the end you're gonna, depending on some states will allow insulation contractors to install heat trace, and they will install it and then put the insulation over top of it.
Okay.
So I'll work with the different disciplines, and they all, mechanicals will need a little bit more support, a little more training on the electrical side. Electricals need a little bit more help and training on the mechanical side.
How is technology changing, these systems?
Yeah, so for heat trace, the actual technology of the trace itself hasn't changed much in the last 20 or 30 years.
Sure.
What has changed is the control systems.
Okay.
There's newer, more sophisticated, and lower cost electronics available these days. When I first started with Valen, you might see a lot of mechanical thermostats because they were just less expensive, and you just wanted something to turn it on and off. But now for just about the same amount of money, you can get an electronic version that is going to control a little tighter temperature. But more importantly, it's going to have feedback. It's going to let you know if there's a problem. It's going to let you know if you lost power, if the temperature has decreased on the pipe, if you've got a ground fault situation. You can get a lot of information back, and just even on an alarm letting you know that there's a problem, or a bus network that will actually tell you what that problem is back at your BMS.
Does leak detection have similar types of communication and data and all that?
Yeah, they do. Leak detection is also, it's probably even more important for leak detection to have a remote communication to the BMS, because you're typically in an area that you don't have people going back and forth looking for leaks. And if there is a leak, you want to know about it before, next week when somebody is kind of expecting it. The sooner you know, the sooner you can address the problem. So leak detection, typically you're going to have some sort of remote signal sending back to your monitoring building management system.
I was just thinking about, heat trace maybe as more of a continual monitoring situation, because you want that temperature to be constant, and that environmental conditions could be impacting that. And like you said, maybe there's breakdowns in the system along the length of pipe or something. But on leak detection, is it possible that people are okay with a level of leakage, like it's acceptable, and then they can monitor that way, or is that not true?
Yes. There is some where customers don't care if it leaks a little bit. A few drops here and there is not a big deal. It may just be something that is leaking from the filter or something like that. They really just want to know if it's a big leak, and when that event happens, they want to address it right away. Yeah. In some cases, that can be the problem with the technology. A little leak or a big leak will set off the alarm, and really they don't care about that little leak. They just want that big leak. That's when choosing the right technology can really help, because there are technologies out there that that can differentiate between big leaks and little leaks.
Another thought I had is both of these things can be out in areas that are remote. Are there different powering solutions to those, like local, like a wind or solar or something that can power these things where it's tough to run? You can't just pull out an extension cord.
Right. Well, heat trace Heat trace requires a certain level of power.
Yeah.
That one, no, you're going to have power available from something.
Okay. Okay. That makes
But
sense.
leak detection, it really is not a lot. It doesn't require a lot of power to run the system. Just
Mm-hmm.
it's just a very, very small amount of wattage
Okay.
that is required. So there are systems that can run off of batteries that will
Okay.
last 10 years out
Oh,
in
I
remote
got you.
sites where you don't have access to power. Even cellular devices, we found that that we will use depending on how often it's sending back a signal. They can have years of life on a battery. You just need to go out maybe once every year or two and replace the battery.
Got you.
Those systems typically tell you and send you a signal if you have a low battery,
Yep.
let you know. But it is a lot more common for leak detection to be running off of a battery and with no power available.
Okay. All right. Let's talk about smart design for both systems. I'm just going to mix both systems together here and you can differentiate where it makes a different, where it makes sense to differentiate on the two different systems we've been talking about today. But let's talk a little bit about saving contractors or saving end users money, but by designing smarter, not by just saying, hey, I want the cheap thing, but how to design. So where do you see the biggest cost savings in these systems that can help the end user and the contractor installing it?
Yeah, that's it's really the kind of the one of the goals is to do that. I would say the heat trace I can help them the most. I'll come back to leak detection, but on the heat trace side of it, going through the design, making sure you optimize the amount of insulation that's on there to maybe reduce the amount of the watts per foot that's required, or vice versa. In some cases, the overall eliminating the amount of connection points, the eliminating the amount of circuits that are used can all save money. The installation of the heat trace is important as well, though. If it's not installed properly, you're not going to get a consistent result. And once it's insulation's over top of it, you really can't see what's underneath, and you don't know what's going on. And if there's a problem, you kind of have to rip up all the insulation and kind of figure out what's going on. But if you follow standard practices, best practices, you can eliminate some of that. And one of the things I do is help train installers. Sometimes they've got lots of experience. Sometimes they're new to heat trace, and we will train them on what the best practices are, or remind them of what the best practices are. Remind them of where to get resources if they have questions, so that it's installed consistently along the whole system. And sometimes it's a matter of looking at some piping, and instead of just starting to lay it out, you actually come up with a plan and a strategy on how I want to lay this out, so that you don't lay it out, realize that really probably didn't work very well, and have to take it all up again. Having to take it off and then reinstall it is going to cost a lot of time, which is probably one of the costlier problems that contractors run into.
If listeners, contractors or end users are going to take only one thing away from this conversation, what would you want it to be?
Well, I think there are times when it may just be easier to put out a bill of material and have someone provide a list of products. But I think it doesn't hurt to talk to somebody that has some experience in both heat trace and leak detection, really both applications, and just go through the application, make sure you've got the right product, make sure there maybe isn't a better installation design, don't be afraid to ask to have someone come out and help you train on the installation. We're there to help support, and ultimately we want the end user. We both want the end user to be happy with what they're getting.
Yeah. Yeah. I guess kind of what I'm taking away from this is, um, reach out to your, the expert that at your distributor, at your manufacturer, whoever, and maybe just ask, hey, what questions should I be asking? What do I need to be thinking about here? Because you may not even know. Like, I don't even know what
Right.
the questions I should be asking, right? So maybe that's one way to start. Hey,
Yeah.
John, I like to close the conversation by focusing on the why of what we do.
Okay.
So what motivates you to do this day in and day out? What keeps you excited and passionate about what you do?
I think kind of links back to what I said at the beginning. I like to learn new things,
Mm-hmm.
and in this industry, um, it's changing so quickly. Data centers are changing the way they're cooling their servers. Um, Semiconductor and AI is pushing new technologies. Learning and keeping up with all that is to me fascinating, and I think it's gives me the passion to continue to learn more about what they're trying to do and where they're trying to go, um, and keeps me happy with what I'm doing.
Yeah, great. Hey, John, thanks for taking a few minutes and spending some time with me to educate me on these new areas that I hadn't thought about. And I know you've educated some contractors and end users on some things they can think about in these very specialty niche areas of the electrical world. So thank you so much for that. It's been great having you on the show. Thanks a lot.
All right, thanks, Todd. Thanks for having me.
Well, that was my conversation with Jon Irvine from Valland Corporation. You can connect with John and what he is working on by heading to the links in the show notes. I would love to hear what specialty systems are giving you the most struggles, hurdles, troubles, whatever you want to call it, and how are you overcoming that? Leave a comment in the comments section of Spotify or YouTube. Or, more importantly, as I mentioned in the intro, I'm building up a newsletter community and would love to chat with you about these questions via that medium. Please click subscribe in the notes section or at graybar.com/podcast. Hey, if you've enjoyed this episode, you can help us grow the show by subscribing and leaving a 5-star rating in your favorite podcast player and YouTube. Thanks for listening to this episode of Keeping the Lights On. We'll see you next time. All right, what advice would you give to 18-year-old John?
Well, I think I would tell my 18-year-old self to travel abroad. Something that my kids are both in college and have done some study abroad, and I completely promote it. They've come back and learned so much about other cultures, other languages. I wish I would have done more of that. I would have told myself when I was 18 to maybe do a few trips before I started a career. To just kind of do that. But I would also tell myself to, I think, embrace change.
Okay.
Continue to have a passion for learning, which kind of goes along with studying or going abroad, learning about other things. There's a lot to learn out there, and I think learning new things is very rewarding. At least it is for me.
Yeah.
And, there's things that are always changing. So if you're not embracing it, it can be a problem.
Yeah, for sure.